Greetings and welcome to TALE Module 3 Unit 16 on Instruction for Metacognition. In the earlier unit we understood the instruction for design. Now in this unit, which is very completely different from the previous topic, we aim at understanding the need for and methods of instruction for metacognitive learning. This area, metacognitive learning, is somewhat new to majority of the faculty, so it requires some amount of spending time in understanding all the terminology, its role and what is to be done about it. But once we understand that, we will be able to appreciate the central role that metacognitive learning plays. We talked about metacognition in the TALE module 1. Let us when we were talking about the taxonomy of learning, and metacognitive knowledge is one knowledge category in the as per Anderson-Bloom taxonomy. Now we said at that time, metacognition is thinking about one's own thinking. It looks nice, but we need to understand what exactly it means. Or it is the ability to assess our own skills, knowledge or learning. That is what is metacognition. Do I understand what is it that I can do, or what is it that I know, or whether I am learning or not, whether I have learnt or not. It is also a person's awareness of his or her own level of knowledge and thought process. Now obviously based on this, based on our own metacognition, that ability affects how well and how long students study. For example, if I already know that I know a particular topic very well, I will not spend time on that. But if I know that I do not seem to be completely understanding, then I will spend more time on that particular topic. So the amount of time I spend in learning a particular topic will obviously depend on my metacognitive knowledge, and also it influences how much and how deeply the students learn. For example, I can superficially learn and claim to myself that I have learnt, and then I only realize when some questions need to be answered, my learning was not adequate. So metacognitive ability affects how well and how long students study, how much and how deeply the students learn. Now how does it get translated? All this gets translated into, let us say, a day-to-day activity either for the teacher or for the student. Metacognitive ability means using learning goals, success criteria and descriptive feedback. All the terms are very clear. That means how do I use my learning goals, how do I use my success criteria, and also how do I understand the descriptive feedback given to me. Recognizing how attitudes and habits influence learning. Identifying, communicating and acting on learning preferences and strengths. Assessing learning situations and developing plans of action. Reflecting on learning and engage in conversation about one's own thinking. I think this is one skill that everyone should be able to develop, reflecting on learning. That means how did I learn, what is the process that I have gone through, and where did I find difficulty, how am I judging my learning, and with regard to that I must be able to engage in conversation with somebody else also about my own thinking. The more we do that, the more metacognitive ability that we will get. And also we need sometimes we do not fully understand something, that is we should seek clarification and support when barriers to learning are encountered. So, if you are able to do all these things in your day to day learning activity or even teaching activity, then we have that metacognitive ability. And why should we be concerned about metacognitive ability or metacognitive activities? And it is quite known, high performing students have better metacognitive skills. That means in an institute, let us say a high end institute like you have IITs, NITs, where the students are selected through a very long process, by and large they are high performing students. And high performing students implicitly have better metacognitive skills. So, in an IIT or in an NIT, if the teacher does not spend much time on metacognitive instruction, it may be okay, because people are able to, they already have that skill, that ability. But weaker students typically have poor metacognition besides other things. And this is where you have about almost 90% of engineering colleges, if you have, they all have fairly significant percentage of what you may call as weaker students. And they will have poor metacognition. Their learning is influenced by their poor metacognition abilities. So, you can say poor metacognition is a big part of incompetence. By the time the students enter the higher education institution, and if they are weak students, and one of the elements of their weakness is poor metacognition. For example, students with poor metacognition skills, that poor metacognition reflects in shortening their study time prematurely. They read for little time and I think they have understood, and they will not continue, thinking that they have mastered course material that they barely know, or they become grossly overconfident in their level of understanding, or underestimate or overestimate their performance in tests and make poor study decisions. If you ask a poor metacognitive student after the test, he may feel very confident that he has aced the entire paper, or otherwise he will just declare that I have not done anything well. So, he is not able to realistically estimate his performance, and because of that they make poor study decision. How much to study, when to study, what to study, they will make poor study decisions. Now, we look at the elements of metacognition. We briefly looked at this in our earlier unit in tail 1. The three elements are metacognitive knowledge, metacognitive monitoring, and metacognitive control. And in the literature, monitoring and control are together referred to as regulation, as metacognitive regulation, by many authors. Even today, many research papers do not separate monitoring and control, whereas in some parts monitoring is a separate process and controlling is a separate process. Now, let us look at metacognitive knowledge. Do you have the knowledge of tasks and the content? Simple. Do you understand the task? Do you know what is to be done? Do you understand the contents that are presented to you? That is what knowledge of the tasks. And the other one is knowledge about cognition and cognitive strategies. For example, the metacognitive knowledge is considered to be declarative knowledge and procedural knowledge. But now the declarative knowledge of what different types of strategies are available for memory, thinking, and problem solving, because these are the three activities a student is likely to be dominantly getting involved. That means what strategy do I know what strategies I have for transferring from temporary memory to long term memory. What are all the strategies that I have? Do I know of those strategies? Similarly for thinking, similarly for problem solving. So am I aware of these strategies? And similarly, we also this knowledge refers to procedural knowledge, how to use and enact different strategies. And conditional knowledge is when and why to use different cognitive strategies. So as you can see, knowledge about cognitive strategies, these are the ones that are available. And am I aware of it first? First of all, if I do not know any of these things, I haven't read about it, obviously I do not know. Knowledge of one's own strengths and weaknesses as a learner or thinker. So this is the third aspect of metacognitive knowledge. Do I know my own strengths as a learner? Do I know as my weaknesses as a learner or thinker? This classification or this elaboration of metacognitive knowledge is to Plintrick and other authors. Now coming to metacognitive monitoring, I should be able to observe what is happening. Metacognitive monitoring is defined as assessing the current state of cognitive activity. Like this consists of task difficulty as ease of learning judgments. That means I am making a judgment. Making an assessment of how easy or difficult a learning skill will be to perform. So I should be able to, through monitoring, I should be able to make an assessment how easy or difficult a learning task will be to perform. Monitoring of learning itself, that means I am making a judgment to what extent I have learned that particular topic, how far I have to go. So this is where I am with respect to learning that particular topic, that is monitoring. And also I should be able to monitor the feelings of knowing. For example, having the experience of awareness of knowing something but being unable to recall it completely. So this kind of feelings of knowing is also part of monitoring. And then third part or next one is confidence judgment, making judgments of the correctness or appropriateness of the response. For example, if I have responded to something, am I able to make a judgment whether I have done it correctly or not? And that means if I made a judgment that it is correct, then my confidence in judgment will increase. So these are the four elements of metacognitive monitoring. And based on this, we go into metacognitive control. That means based on the monitoring, we should be able to regulate some aspect of cognitive activity based on cognitive monitoring. What aspect are we regulating? One is planning activities. Planning activities means I should be able to set goals for learning, time use and performance. I set the goals, so by such and such time, by tomorrow, I should be able to prepare a set of slides for this topic. And how much time do I generally require for that? And how well I am going to do that? So planning activities, then strategy selection and use, making decisions about strategies to use for a task or when to change strategies for performing a task. So not only you are setting goals, but you are making decisions about strategies, and also under what conditions you will be changing the strategy. So I should also know that. Then allocation of resources, control and regulation of time use, effort, pace of learning and performance. And fourthly, volition control, control and regulation of motivation, emotion and environment. Because when we are working, we may not have that much control over the environment. Let us say it is very noisy. So I need to control that. and I'm not feeling very nice about it, rather I'm feeling negative about something. So I should be able to regulate or control my emotions as well as motivations. Metacognitive control decisions influence the direction and the manner in which learning will continue. All these 4 activities, most of the times we will be doing that, but without being fully aware of it, or we may not be able to perform these activities properly because we are not aware of it and we do not know what is, or earlier, for example, we haven't been able to monitor properly. So once people are trained, students are trained in doing this a few times, then it starts becoming second nature to the students. But if somebody is poor in metacognition, he needs to undergo this experience several times until he picks up the required skill. And why we can consider why we want to examine metacognition. In today's context, we require the ability to engage with and transform increasingly more information across a single or multidisciplinary context. Everything that we need to know, it cannot be pushed into a formal curriculum. Depending on the task that you are working on, you may want to constantly access new information which is available today on the internet, or readily there is considerable access. So one should be able to engage with a lot of information across a single discipline or multidisciplinary context. And also, as access to information is continuously increasing, the process of accessing, choosing and distilling information will become a major task. Sometimes when you Google, you get endless amount of information. So you cannot waste your time in trying to read everything and distill information from that. So one of the skills that you require, it's a metacognitive skill of distilling information. And these days, institutions and educators require students to undertake independent learning in increasingly less directed environments, or autonomous learners. Anything and everything cannot be taught in the classroom using a chalkboard or a projector. Some things are touched briefly or overviews are presented, and the students have to work out the details. So what happens is, every detail is unlikely to be presented in today's classrooms. So one has to become an autonomous learner. A good autonomous learner is also a good metacognitive person. And to achieve these 3, that is, ability to engage with increasingly more information, or distill information, or to become an autonomous learner, one of the best methods is fostering metacognition learning. There is one method of achieving this. So who is a metacognitive person? Metacognitive person is someone who monitors his or her understanding and uses strategies to regulate understanding. So one is, you should be able to monitor, and the other one, use strategies to regulate understanding. It also means that there is also a what you call a non-metacognitive person. When there is a metacognitive person, there is also a non-metacognitive person. And if one of the goals, not if actually, one of the goals of engineering education is to foster independent learning, which is stated as program outcome 12, called lifelong learning. So if you want to attain PO12 through your engineering program, it is necessary to prepare learners as metacognitive persons. You can't promote, you cannot establish that a student is a lifelong learner. The main route is through make him a metacognitive person. And because of that, teachers need to understand how to improve learners' metacognition. Now we come to the teaching. Metacognitive teaching. Teaching metacognitively includes teaching with metacognition and teaching for metacognition. First one is related to the teacher and second one is related to instruction. Teaching with metacognition means teachers think about their own thinking regarding their teaching. They are thinking about their own teaching. Teaching with metacognition includes reflecting on instructional goals. That means teacher should be very clear about what are the instructional goals, implications. It is not mere repetition. He must really understand the depth of the instruction goal or at what level it has to be done, how important it is, how it is related to other instructional goals and so on. And he should also should be able to reflect on students' characteristics and needs. As we said, all students in all institutions are not the same. So each groups of students have their own characteristics and needs. And content of all courses are not the same, content level and sequencing, teaching strategies that you want to use, the materials that are available to you, and other issues related to curriculum, instruction and assessment. So one is the teaching with metacognition requires reflecting on all these issues. And again, watch out, it is a continuous process. Such thinking occurs before, during and after lessons in order to maximize instructional effectiveness. So that is teaching with metacognition. Now teaching for metacognition. Metacognition can be promoted through you should note some of the universities on their websites, they talk about many of the they take a position with respect to many of the pedagogical issues and they keep some material for ready reference by the faculty of any particular branch. So I am just quoting from Vanderbilt University that metacognition can be promoted through encouraging students to examine their current thinking. That is, what do I already know about this topic that could guide my learning. So first thing is that. Then giving students practice in identifying confusions. Sometimes it is not clear, a statement may be confusing to the student, but the student should be able to articulate what was most confusing to me about the material explored in the class today. Something I have listened to the class, but it is confusing. At what point of time it started becoming confusing, will I be able to identify? Or pushing students to recognize the conceptual change. For example, before this course, I thought, here for an example, stability of a system meant such and such. Now I think stability is. So there is a conceptual change has occurred. I am recognizing that. That means I should be able to, students should be able to write, prior to this was my opinion or this is my understanding, but after learning this is how my understanding changed. He should vocalize or sometimes write it on a piece of paper. If you do a few times, it makes a tremendous difference to your way of thinking. So you are keeping track of how your thinking is changing over time, and this awareness of the changing with over time in a conscious way makes you a metacognitive person. Further, one of the tools is reflective journals, providing a forum in which students monitor their own thinking. So you ask your students to write their own journal. What about my exam preparation? Preparation worked well that I should remember it to do next time. Let us say I did something right. Can I note it down just to make sure that I can use that next time? If something did not work so well, and I should not again waste my time in doing or using that particular method. Okay, this kind of thing a reflective journal. That means I am reflecting on what I have done. That's the kind of thing one can encourage a student to maintain. It is only for the eyes of the student rather than for anyone to make judgment on that. Now, instruction in metacognition should be embedded with the content and activities about which students are thinking. It is most effective when it is adapted to reflect the specific learning context or specific topic, course or discipline. What it means, the instruction in metacognition should not be general. It should be done in the context of a specific course or a part of a specific course. Okay. In explicitly connecting a learning context to its relevant processes, learners will be able to adapt strategies to new contexts rather than assume that learning is the same everywhere and every time. For instance, students' ability to read disciplinary texts in discipline appropriate ways would also benefit from metacognitive practice. So the way instruction should take place is with respect to a specific course, and once you have learned that learning becomes generic. That means once I have learned to if I can become a metacognitive person, then I will be able to apply that into some other context as well. But learning will be in a identified context. Now let us take, for the sake, one case of introductory programming course. Internationally, this has a very high failure and dropout rate. It has been known. And in India, most engineering institutes achieve a high pass percentage in this course, and dropping out of the course is not an option because it is compulsory. And the institutions, how did they achieve this? By making students learn a fixed set of programs, not programming. So somehow system adapted itself in achieving high pass percentage by finally converting the course into learning a fixed set of programs. And the assessment methods are also based on students' ability to reproduce these programs in the lab. That means the teacher presents there are fixed set of programs 20 or 25, and the teacher presents these programs, only one code is presented on the board, and the student should be able to remember that, reproduce that code and run it in the laboratory. You are not supposed to change the code, even if it is you produce a more efficient code. So what happens by somehow system adjusting to this, you made the students learn a fixed set of programs, but they woefully perform with respect to programming. A survey established that students lack metacognitive awareness both in terms of metacognitive knowledge and regulation, or what we are calling monitoring and control of cognition needed for writing programs. So the major problem seems to be the lack of metacognitive knowledge and regulation. And also another survey established that good grades do not mean good programming skills. Even if somebody got an A or S, it does not mean that he is capable of programming. There is some issue with regard to this particular course itself. Learning programming involves the acquisition and effective use of 3 interrelated types of programming knowledge. What are these? One is syntactic, specific facts about programming language and rules for its use. This is what is normally presented in the class. That is, all the syntax is presented. Then you have conceptual, computer programming constructs and principles. How do you really create call it an algorithm based and interpret the problem from that? okay, that is conceptual, and then strategic. Program specific versions of general programming specific versions of general problem solving skills. So these three areas, and what happens, most of the introductory programming courses seem to foster the development of syntactic knowledge and not put enough emphasis on the development of conceptual knowledge nor strategic knowledge, which is left to unguided discovery. When it is not explicitly dealt with in the classroom, then the students will have to discover by themselves, which is not, and you are not guiding that process. So what happens, because of the large amount of programming instruction involves letting students proceed by trial and error, as if the ultimate instructional goal was simply to get the programs to work. Okay, that is what has been happening in many institutions. So what is the consequence? Students tend to develop a fragile knowledge of programming, described as garbled or inert knowledge. That means you know a set of programs. Essentially translate like this: you write out of the 20 standard programs, there is one program to find the area of a rectangle. If you ask the student to find the area of a triangle, almost 90% of the students seem to be failing. So that means they have inert knowledge, but they are not able to appropriately kind of change understand the new context and slightly alter the code. And they use the knowledge inappropriately, or knowledge not spontaneously accessed in the context of need, because it is still welded to the initial context in which it has been acquired. So constantly you are only familiar with one context, and then you are not able to adapt to changing context. So what can be done? Working with several groups of students at different institutions established, metacognitive formative assessment helps students plan and invest time in learning programming, even in the social context where learning programs will be enough to pass and score good grades. So as you can see, it's a big barrier. That means if I only learn programs, I can get good grades. So there is not much motivation for majority of the students in participating in any metacognitive formative assessment. A small number of students who are serious about learning programming, then they have participated in these kind of exercises. But it should be done as a matter of routine. And in general, what can be done about metacognitive instruction? First thing is, metacognitive instruction will be context and content specific. That we have stated. But the metacognitive learning is generic in nature. So what should we do? A few courses in the first 2 years of engineering program should be targeted for a deliberate metacognitive instruction. So how do we choose these courses? You can take a maths course, you can take a programming course, you can take a descriptive course, you can take an engineering science course, or even an English course. A few, 5 to 6 courses can be targeted. That means the instructors for those courses should be trained to deliberately include metacognitive instruction. Now what we request you is, write a few instances of metacognitive instruction in your course, even though you did not use or you are unaware of the terminology associated with metacognition earlier. But once you get familiar with you should get familiar with the terminology of this through this particular unit, and now you can look back whether there were few instances of metacognitive instruction in your course, and if so, please write those few instances as bullet points or a short paragraph or whatever you have. And we will thank you for sharing the results of these exercises at this address. And in the next unit we will look at this that will be the last unit of the tail. And now in the especially module 3 we might have given you a lot of information, or there are several elements possibly not sequential, not exactly interconnected with each other, some of them like different methods of instruction. Okay. Now with all this knowledge, which is not strictly like a single topic, how should the teacher proceed? How should the teacher make use of this? That is what we will look at in the last unit of this tail, module 3. Thank you for your attention.